a crystal form or a solid form. It has to be drawn into the wire form which can transmit the electricity from one end to the other. This is what is the requirement as on today. If somebody, some of you, invents new material, I assure you will get a Nobel Prize. This is very, very important because it is a demand of the system now. If you have new materials, yes, it is going to be the success. Another interesting aspect is the bonding. You know, all of you know that when you study chemistry, you make bonds, right? Bond between two atoms. So what is the role of electron here? It is like a glue between atoms. It is like a paste between atoms. Electron binds two atoms together, a number of atoms make a bond, and that is very, very interesting. See the chemical bonding. All of you know many bonding, right? So what are the bondings you have studied now? Good, memory is good, yeah? So sigma bond we say it, the covalent bond, right? Pi bond we say it is also a covalent bond. What is the basic difference between the sigma bond and pi bond? Direct overlap and lateral overlap. Do you know there is one more pi bond? Bilateral overlap. Sigma pi. What is the next bond? Delta bond. Good. There is an answer. Delta bond. So what's the delta bond? Is a lateral overlap between the d orbitals. We have the d orbitals. எத்தனை பேருக்கு d orbital தெரியும்? அது அடுத்தபடியா ஒரு ஆர்பிட்டல் இருக்கு. அது என்ன ஆர்பிட்டல்? Very good. So you have f orbital, right? So the sigma, pi, delta. If there is an overlap between the f orbital, what will you call it? Right. What is the bond you call it? Lanthanide is fine. It's the family of the elements. But if there is a bond between the f orbitals laterally, what will you call it? Sigma, pi, delta, next letter. Sigma star. You like superstar? Okay. You like superstar, I see that. That's the reason I put a star on that. Gamma. You can say gamma, right? It's a nomenclature, basically naming. Naming given, yes, let's settle down, right? So the nomenclature is very important, and that is where you get a different bonding system. For all chemical bonding, important particle is electron. Without the electron, no bonding, right? So the bonding materials that are available in nature, many, right? இந்த யுகத்துக்கு முன்னாடி இருந்தே இருக்குது. இந்த யுகத்துக்கு பேர் என்ன? யுகம். இதுக்கு முன்னாடி யுகத்துக்கு பேர் என்ன? உங்க தாத்தா பேர் என்ன? உங்க தாத்தா பேர் என்ன? That's a problem. So we don't want to understand our ancestors. There is no connection. That is the reason why Lord Krishna has shown up again every Bhagavad Gita, because connectivity lost. So like this, we have to carry the message, the connection, and that is where you see it. Connections between atoms are very important. They have been existing, but we have been realized only from the last century, right? It's interesting, you see that only after the discovery of the electron, we realize so many bonds between atoms, materials. So we talk about ionic bond, we talk about covalent bond, we talk about coordinate bond. We also talk about other weak bonds like a hydrogen bond. Now if I tell the hydrogen bond is very weaker, some of my chemistry guys will kill me, because now it is claimed as a very strong bond. Just I was told that Gautam was here in the morning, he gave a lecture, DNA, how you are viewing DNA. Helical structure that you are seeing in DNA is because of hydrogen bond, right? So hydrogen bond is also one of the strong bond, you can claim it now. Now look at this, all this phenomenon application, how exactly technology was coming up, electronics, right? Without electron, no electronics. Is it possible? No. So electronics has given you semiconductor devices, semiconductor devices. So now you can see that ICs, memory devices, you can see these are all coming out of the principles of the electron. And how do we make integrated circuits again? Using the photons. They've been making all these integrated circuits. I'll slowly do that a little later. Using photons, called as the technology lithography. Lithography again came up from the printing technology. So they used it from printing technology. Now we talk about welding. We talk about electric welding. We take electrodes, deposit materials, weld two materials together, and you use the gas discharge and then melt the material and discharge. You can also use the electron beam to weld it now. Electron beam welding is possible because of the higher energy that you have it with the electron beam. Cathode ray tubes, electron microscope, radiation therapy, now treatment in medicine, they use it for cancer and radiation therapy. Another interesting aspect, interesting invention that has taken place in the last century, lasers. In which year lasers were invented? Anyone knows lasers invention? 1980. You like? 1980? No. 50 to 60. 50 to 60. Broad range. The right year is 1960. 1960 was the right year. The laser were really invented, and after the invention of laser, the scenario has changed a lot, right? Your computing devices have changed a lot. Your memory device, what I am using is also a laser. What is this laser? Right, what is this laser? Yeah. Laser is an acronym you are trying to say. What is this laser?
Concentrated.
Concentrated solution.
Light.
Light. How do you concentrate light? Yeah.
I mean, like focus light. Focus. It's a light focus.
Now I will ask the question a little more explicitly. What is the color of this laser? Red color. That much you know, right? This color is always easier to find out. Red color. Fine. How do you get this red color? Anyone can get up and tell me what is this? Otherwise, I will ask a question, what is the material from which this light is coming? Radiated photons is a light, yeah? What is the material from which? I am talking science. This I am talking, yeah? This is coming from my mouth. And this is the material from which the laser is coming. So what is the material do you think? The end of Purul. Purul, very good. Solid laser. That's what material is.
Some metal.
Some metal. It is basically a semiconductor laser. It's not silicon. The semiconductor laser, you have to find out that. It's a semiconductor laser. We are using it. I'm going to give you that also. You can have a gaseous ionization. You can have a detectors out of this. I want to detect light. The best detector, everybody has a mobile these days. And you have a nice camera behind this mobile. What is this camera is made up of?
Lens.
Lens? Okay?
Light sensing.
Light sensing.
Means captures light and makes a photo.
Light? Sensor. We call it sensor. Detector otherwise. What is the detector? We also have sensors. You touch, you have a sensing motion, sensing action. Now, camera is a mobile or camera. What is it made up of? Photons. Photon sensor. It's a light sensor. Okay, fine. But what is it made up of? எங்கேயோ போயிட்டோம். நமக்கு முகத்தில் அழகான 2 கண்ணு இருக்கு. அந்த 2 கண்ணு டிடெக்டர் தான். இல்லையா? அது என்ன பொருளால உருவாக்கப்பட்டது? இது நீங்களே நானா உருவாக்குனதல்ல. கடவுள் மேல நம்பிக்கை இருந்தா கடவுள் கொடுத்தது இல்ல இயற்கை கொடுத்தது. கிருஷ்ணன் லென்ஸ். டிடெக்டர். What is the detector? தமிழ் ஒரு பழமொழி இருக்கு, கண் இருந்தும் குருடனாய், காது இருந்தும் செவிடனாய், நம்ம எல்லாம் படித்த முட்டாளாய். சொல்லி தலை குனிஞ்சுக்க, நேரம் நின்று தான் சொல்ல, தைரியமா சொல்லு. எழுந்து சொல்லு பார்க்கலாம். சொல்லுங்க. Anybody have an answer?
Sir, what's your question?
Question புரியலையா?
Sir,
நம்ம எப்படி கண்ணால பாக்குறோம்?
sir, rods and concepts.
Micro?
Sir, rods and concepts.
Rods and cones, okay. Rods and cones என்னது? Rod, cylindrical rod, cones, conical shape. What is this material here? What you are saying is the shape of the material.
No,
I want
sir. Cell name.
Retina is the screen. Right. That is where the material is present. Right. Let me give you the answer. Please settle down. Settle down. It is called as the rhodopsin. It's an opsin. It's a chemistry molecule. Chemistry molecule. Yeah? It's an organic molecule. It is present in the shape of the rod shape of the protein. That is what is called as the rhodopsin. Right? Rhodopsin. When the light is falling, what is happening? What is happening? How do you see it? There is a chemical reaction called as the isomerization reaction. Photoisomerization reaction. We have a beautiful detector in your body. It is sensing by photochemical reaction, photoisomerization reaction. How much time this reaction to take place?
1/16.
How much time? Nanosecond. யாராவது கரெக்டான ஆன்சர்? எவ்வளவு நேரத்துல இந்த ஃபர்ஸ்ட் ரியாக்ஷன் நடக்குது?
1/16.
1/16.
Half a second.
What? 1/16 length or meter or what?
Second of 1 second.
1/16 seconds. That's all. Okay. 1/16 is not a small number. Just 1/10 and 1/20. That's all. Nanosecond is how much time? 1/16. 1/16 is nanosecond, is that? Minus 9. 10 power 9 is giga, yeah? 10 power minus 9. Very good. Minus 9. But it is much faster than that. It is happening in picoseconds. Minus 12 seconds. The primary photochemical reaction time scale is something like 100 picoseconds. Isomerization. You see that? Which is the very fastest detector in the world today. To tell you honestly, right? What you see on the air, fastest detector is this. You don't have any other faster detector than this. Man-made detectors are only few closer to that, but this is much faster. You know why? It was not made by man. So you see the engineering behind it. Who is the engineer of this? That's what we believe, right? There has to be an architect of this body. There is an architect, there is a scientist, there is an engineer. So many things involved in it. But even today, we have created so many engineers, so many scientists, they are not understood many things, right? That is what is the curiosity you should build in yourself. Go for that kind of research, and that is very important thing, right? So now detectors are very important, and you can also accelerate electron. Electron speed you can accelerate, right? So anybody has studied about accelerators? என்னப்பா தமிழ பேசணுமா? ரொம்ப சலசலப்பா இருக்குது இங்க. கொஞ்ச நேரம் டைம் லஞ்ச் டைம் இன்னும் ஆகல. 1:45 ஒரு பாட்டுக்கு லஞ்ச் டைமா? ஸோ 15 நிமிஷம் முன்னாடியே சொல்லிருக்கீங்க. Okay, 1 o'clock. Fine. The particle accelerators. So now you can accelerate linear accelerators. You have studied about cyclotron, like this. You can, how do we speed up it? Using the magnetic field, right? Magnetic field Because of the magnetism and electricity, one can drive the electron. உங்களை டிரைவ் பண்ண எப்படி பண்றது? உங்களை டிரைவ் பண்ண எப்படி பண்றது? எலக்ட்ரானை டிரைவ் பண்றது ஈஸி, ஆனா உங்களை டிரைவ் பண்றது ரொம்ப கஷ்டம். ஏன்னா எலக்ட்ரான் மாஸ் ரொம்ப கம்மி, ஆனா நமக்கு மாஸ் ரொம்ப ஜாஸ்தி. நம்மளை டிரைவ் பண்றது அவ்வளவு ஈஸி இல்லை. சேர விட்டே இருக்க மாட்டோம் அவ்வளவு சீக்கிரம். Right? So that is the problem. Electron is so light that it is easy to drive. Right. Let's go to the photon. See the speed limit of photon. Photon. Right? So I have given in kilometers. 3 into 10 to the power of 10 meter per second or centimeter per second. 10 to the power of 8 meters per second. Very good. It's the same centimeters. 10. 3 into the 10 to the power of 10 centimeter per second. That is the speed that so far we know it. Many people have discovered or trying to invent or trying to estimate the speed of the light. And earlier it was measured in the year of 1676. They are not really that it is photon. They know there is a light. They are trying to measure the speed of the light. Fine. Many people have measured the speed of light. You know, I have given you a table, how many people have tried from 1676 onwards. Finally, some final value has been adopted. It's almost closer to 3 into the power of 10. Right? That is how there were error bars in all your measurements. They were trying to take the number 3 into the power of 10. Right? Many people also have a feeling light is always traveling through a medium. They call this like an ether medium. But later on, thank God, Einstein has given you the right answer. There is no such medium, no ether. It is traveling in vacuum also, right? And the speed of the light is the same in all directions. That also he has given you. And this is from the Michelson. And you should also know many cool things. The light is not hot. The light that you are getting from this, is it hot or cool? Hot. Light that you get from this is hot or cool? What light is that? White light. Very good. We call this like a tube light. Right? How many of you know this tube light? How it works? That is where the curiosity comes up. Phosphorus. Neon gas. Okay. So, do you know what is the color of the neon? Neon is not white light, yeah? It's color light. Argon is also color light. All inert gases give you color light. So, there is interesting behavior here. Let me give an answer here. Carefully listen. There is an electron also inside. Interestingly, there is an emission of electron. Where is the electron? You can see the two ends having a filament. What is the filament? Tungsten filament. You heat up tungsten, they emit electron. You see the source of electron is heating up any metal that you use it. Tungsten, they heat up, they emit electron. There is a gas inside. Basically, they use a low pressure mercury gas, mercury vapor. And the electron interacts with this gas, they excite the mercury atom. The electron is exciting the mercury atom goes to the higher energy level, they start emit light. Right? நம்ம கூட மேல உலகத்துக்கு போயிட்டு என்ன பண்ணுவோம்? ஒரு மாதிரி சக்கரம் போட்டுவோம். Okay. Right? So they emit radiation, right? And they have a radiation emission coming up from the excited state atom, and they excite the molecules or materials coated on the inner surface of the tube light, and that is basically inorganic phosphors. Inorganic phosphors are a mixture of zinc oxide and mercury oxide there, right? And they emit white light. So there is an electron exciting the gaseous form of the mercury. In turn, they excite your inorganic phosphors. You get a white light, cool light. That is what I say. The cool thing to know about light, what are the cool things light refracts? Light beautifully refracts. We are already studied about refraction, refractive index. We also know refractive index of the medium, and this is how the refractive index helps you to focus your light. Put a lens in front of the light, refraction always helps you to focus the light, and it also dispersion. Dispersion is possible. When you put a prism, you can convert, otherwise separate the white color into its components. With GR you always say, and that is what is your colored light. Refraction, they also reflect, right? And you also have the internal reflection. It is a total internal reflection is possible, and these all putting together you can have a beautiful phenomenon happening is rainbow. Rainbow is happening because of the total internal reflection. Fine? And you also see that another interesting aspect is diffraction. Diffraction, right? They diffract. These are basically the properties we know is the wave nature of the light. And these properties are very important, and they diffract, they also create interference patterns. You can do a double slit experiment, do an interference pattern. You can have a constructive interference and destructive interference, right? You can have the crest and troughs, you can have it, and you have the interference pattern. Fine. Let me see this. Right. So like we can say, based on this, is a wave nature. Wave nature. You have a wavelength. You have a beautiful wavelength coming up for the light, and lambda is equal to C by U. So the frequency, speed of light, and wavelength. Right. So where you can see the crest and troughs